Hello. In this video, I will show you how you can create and edit patches on solid surface meshes. Let's first launch a new configuration in Interface Equilibrator. Then, we'll load a new solid surface mesh. Selecting a planar mesh. We regulate its size and number of vertexes per side, and then we load it. To add a patch to this mesh, we right-click the mesh node in the tree diagram. And then we click Add Patch. Then, to assign facets to this patch, we right-click the patch node and then we click Edit. These tools allow to select which facets of the mesh are assigned to the patch. For example, now I am using the mouse cursor to select mesh facets. Then, by clicking Confirm, the selected facets are assigned to the patch. If I then launch again the tool to edit this patch, I can select new facets to add to this patch. And I can deselect previously selected facets, removing them from the patch. And then I click Confirm to save a new patch. When editing the patch, I can also click Clear Selection to deselect all currently selected facets, or Select All to select all the facets of the mesh. These buttons on the left allow to select all the facets that are within a certain analytic domain. By clicking this button, you can edit the analytic domain. For example, the currently selected analytic domain is a circle with radius 1 micron on the X and Y plane. By confirming this domain, and then by clicking this button, we select all facets within this circle. Instead, by clicking this other button, in addition to selecting the facets within the domain, the existing mesh facets are first split along the boundaries of the domain, allowing the creation of a patch with a closer shape to that of the domain. We can also add multiple patches to the mesh by clicking Add Patch again. And then we can edit this second patch using the same tools. Then, a different contact angle can be assigned to each patch. I have now created a new configuration, reloading the same planar mesh we created before. I now create a new patch on it. Let's now launch the tools to edit this patch. To edit the shape of this domain, you can play with these two parameters, lowercase a and lowercase b. And to regulate the size of the domain, you can use uppercase A and uppercase B. We can now select the facets within the new shape of the domain. And, with this button, we can also split the mesh facets along this new shape. And we can click it again to improve the splitting. If you want to undo the facet splitting, you can click Undo. This is available for as long as the tool to edit the patch remains open. Let's try a different shape for the domain. For example, a square with rounded corners, with side 1 micron. Let's split and select the facets within this domain and click Confirm. We have now created a patch with the desired shape. Let's say we want to add a second shape like this one, and near it. Then, we reopen the tool to edit the patch, and we leave the same shape for the domain. However, we translate the center of the domain in the X direction by 2.5 micron, so that the domain is now located here. We click Confirm, and we can now select the facets within the domain in the new position. We split the facets in between the new domain, and then confirm the new patch. We have obtained the desired shape for the patch. Now we set the contact angle of the patch to 30 degrees, and we leave 90 degrees as contact angle for the rest of the solid surface. Let's introduce a fluid interface mesh to simulate a droplet wetting this patch. As initial volume, we select 8 cubic micron, which is large enough to allow the droplet to spread on both patches. We now will translate the droplet's initial position in between the two patches, so that it can spread over both of them. Finally, we set the equilibration settings. we will launch a first equilibration, keeping the droplet mesh lowly refined and keeping this droplet volume. So, we set the solid surface mesh as constraint for the droplet's boundary. And then we can click Launch Equilibration. This gives us the equilibrium shape for a droplet with a volume of 8 cubic microns. Let's consider a droplet with a smaller volume, say 2 cubic microns. So, we launch a new equilibration where the droplet volume is decreased by 6 cubic microns. And we keep the droplet mesh lowly refined. Now that we have obtained the equilibrium shape for the droplet with the desired volume, we can launch a final equilibration where we allow a higher refinement of the droplet mesh. And we disable the option to vary the droplet's volume. I will now show you a new example to show you that these tools to create new patches can be used also on curved solid surfaces. So, let's consider, for example, a solid sphere with radius 10 micron. Let's add a new patch on it. Then, let's launch the tool to assign facets to this patch. This time, we select an ellipsoidal shaped domain. If we select all facets within this domain, you can see that all the facets inside the ellipsoid are selected, both in the upper hemisphere and in the lower hemisphere. However, let's say that we want to select only the facets in the upper hemisphere. Then, in the form to define the domain's shape, we use this option to specify that only facets within a certain range in Z should be selected. So, we select a range in Z that includes only the upper part of the sphere. And now the only facets that are selected are those on the upper surface. Let's split and select the facets within this domain, and then let's confirm these facets for the patch. We set a contact angle of 30 degrees for the patch, and we leave 90 degrees for the rest of the spherical surface. Let's introduce a fluid interface mesh to find the equilibrium shape of a droplet wetting this patch, selecting 1 cubic micron as droplet's initial volume. We now translate this droplet in its opportune initial position, that is on top of the patch. Then, we set the solid sphere as constraint for the droplet's boundary. Finally, we select the equilibration settings. We keep a lowly refined mesh and increase the droplet to the desired volume, say 100 cubic micron. So, we select a volume variation of 99 cubic micron. We can now launch the equilibration. Now that the droplet's equilibrium shape was computed for this mesh, we can launch a final equilibration to improve the mesh refinement, keeping this droplet volume. Thank you for having followed this video. For more information and for other tutorial videos about Interface Equilibrator, please visit our website.